Okay, so in this video clip I'm going to work through the Calculator Allowed Paper 2 Intermediate Tier paper from November 16. The grade boundaries for the combined Paper 1 and Paper 2 were, as you see here, so 76 out of 160 is what you were looking for in order to achieve a C. So if you were consistent in the way that you performed over the two papers, you were looking to average 38 out of 80 in each of the papers. And what I've done here is shown you cumulatively, if you keep getting every previous question right, that means that you need to get up to and including question 10 all right, and then you'll be in the zone for your grade C. So as I go through the paper, I'll talk through the solutions and also the mark scheme and how the marks are awarded where appropriate. Okay, so let's make a start. So using only the numbers in the following list, write down a prime number. So with prime numbers, you're looking for numbers that only have themselves and 1 as a factor. 2 is the only even prime number, so you can knock out all the other even numbers there and start working with 57. So 57, is it a prime number? Well, if I start with 3, 3 goes into it. It's not a prime number. 59, if I start with 3, 3 doesn't go into exactly, 5 doesn't, 7 would be the next, 7 doesn't go into it, 9, that looks as if it's going to be a prime number. Yeah, so 59 is one of the prime numbers. With cube numbers are what you get if you multiply any number by itself 3 times. It's Calculator Allowed paper, and you've got a cube button which you can see is there. So if we start with 3 cubed, it's 27, 4 cubed is 64. So 64 is the cube number. To find the factors, what you're going to do is you're going to divide 186 by each of these numbers until you get a whole number answer. So 186 divided by 57, no. And there you go. So 62 times 3 would be 186. So a factor of 186 is 3. Sorry, 62. And then multiple of 7.25. You're looking for a number that you can multiply by that and will produce one of these. Or the other way of doing it is to again divide each of those by 7.25 until you get a whole number answer. And there it is, so it's 58. And that's straightforward to mark. For each of those, 1 mark, right or wrong. Question 2. Circle the correct answer for each of the following statements. One angle in a right angle triangle is 60. One of the other angles must be, well, in fact, they're giving you 2 angles there. They're giving you 90 and 60, which adds up to 150. Take that away from 180 and you get 30 degrees. 3 of the angles in a quadrilateral add up to 250. You need to know that the 4 angles will add up to 360. So you're going to be doing 360, take away 250, and 110 is the missing value there. And if he is facing north and turns clockwise until he's facing west, he's gone through that much of a turn, which is 3/4 of a turn, 270 degrees. So again, with that question, those answers are either right or wrong, and if you get them right, you get a mark. Shade the least number of squares in the lower 2 quadrants. So the quadrant is a quarter of the shape, so in that quarter and that quarter. So the grid has rotational symmetry of order 2. Now with rotational symmetry questions, you're allowed to use tracing paper, and it definitely makes life easier. So what you would do is copy the shape that you have. Now for it to have rotational symmetry of order 2, it needs to look identical when the shape has been rotated through 180 degrees. So it looks identical when it's been turned upside down. So what you do is you put an arrow pointing up your page, you then turn your tracing paper around, pivoting about the center, until the arrow is pointing completely down the page. And where the trace ends up are the parts you need to shade in order to give that symmetry of order 2. So once you can see where they are, you shade them in. So that's what you're looking to do. If the rotational symmetry had been of order 4, it would mean it would have to look identical through 4 turns. So they would be quarter turns then, so you'd move from there, where we started, to there, and copy the trace, and so on about the shape. So there's 3 marks for that. There's a mark for that one, a mark for that one, and a mark for that one. So if you're not given tracing paper, remember you can ask for it. Question 4, an equation. So the first thing to do here is to get rid of the -2, to take 2. To do that, you have to do the opposite of taking 2, which is adding 2. If you add 2 to that side, you have to do the same to the other side as well. So it's gone from that side because you've added 2, but you've got an add 2 there. So 3x is 12. Then you need to isolate the x, so you have to deal with the 3. The 3 and the x are connected by a times, multiply, in algebra. So the opposite of times by 3 is dividing by 3, which in algebra we write like that. 12 divided by 3 is 4. A number machine is shown below. In, add 5, multiply by 7, out. So calculate out when the input is -2. So you're going to do -2, you add 5 to that, it's going to take you from -2 up 5 places on the number line, which will take you to +3. You're going to multiply by 7 and you're going to get 21. Write down an expression for the output when the input is n. So when the input is n, you will do n add 5, and then as you can see here, I've then worked that out. So it's been evaluated, So you put it in brackets to say work it out, then times by 7, and that's what the output becomes. So 5 marks on that page. 1 mark for getting down to 3x equals 12. 1 mark for the final answer. 1 mark for 21. And 2 marks here. 1 for the n plus 5 in brackets. And then 1 for the times 7. Right, so if we got everything right up to that point, we're safe for a grade E. Directed numbers. Complete each row of the following table. The first row has been done for you. So if we're going from -3 up to 1, with directed numbers, never be shy. If you're not sure, draw yourself a little number line. Start with 0, 1, 2, 3, 4 in that direction. -1, -2, -3, -4, and so on in that direction. So if you're starting at -3 and you're finishing at +1, what's the change? 1, 2, 3, 4, and it's getting warmer, so you're going up 4. If you're starting at 2 and you're going down 3, so you're starting at 2, 1, 2, 3, you end up at -1. And if you end up at -2, following a rise of 2, that means you are actually 2 degrees lower down, so you're originally at -4. 1 mark for each of those. Doesn't matter if you haven't put the degree C in, it's not asking you to, so it's just the numbers and the signs that are important. Question 6 is a combination of angles on a straight line and angles inside a quadrilateral. We want to find an angle inside a quadrilateral, so we need to know the other 3 and then take them away from 360. So we know that these 2 angles here must add up to 180. So if we do 180, take away 125, and this question often appears on a non-calculator paper, but in this case we can use a calculator if we want to. So that's 55 degrees. So I know that that is 55. So I can now add those 3 up. So 74 plus 117 plus 55 is 246. Angles inside a quadrilateral add up to 360. It's a fact you need to know. So X is going to be what I'm left with once I take 246 off 360. 114 degrees. 3 marks for that question. 1 mark for working out the 55. A method mark for doing the 360, take away the sum of the others, and 1 for the final answer. Question 7. Show clearly whether the following statement is true or false. If you increase a positive number by 10% and then decrease that new value by 10%, you get back to the original number. So with questions like this, you pick a starting value. So let's choose a number, let's say 50. You need to know that if you're increasing by 10%, that's multiplying by 1.1. And decreasing by 10% is the same as multiplying by 0.9, because when you're increasing, you're going from 100% to 110%, which is 1.1 as a decimal. And if you're decreasing by 10%, you end up with 90% of what you started with, which is 0.9. Or on your calculator, you can use your percentage button. So 50 times 110% is 55. So now if you decrease that by 10%, it means that we're going to do 55 times 0.9 or times 90%. So 55 times 90%, and you end up with 49.5, which isn't back to your original number. So it's false. Marks for that. So there's 2 marks for doing a 10% increase. There's 2 marks, sorry, 1 mark for then decreasing that by 10%, and 1 mark for your conclusion that it is false. Question 8. Circle either true or false for each statement given below. So it's all to do with this word, congruent. Congruent means identical in every way. Same shape, same size, identical. So all equilateral triangles are identical. That's false, because they can be different size. If they're equilateral, they've all got internal angles of 60 degrees, but they could have sides of 10 centimeters, 1,000 centimeters, many different, so it's false. All squares with equal areas are congruent. Well, for a square to have a equal area, they are going to be identical, because only squares with the same sides are going to have the same areas. So if you had a square which was 2 centimeters by 2 centimeters, that's the only square that would have an area of 4. So the only way that it would look different is if it was positioned differently, but it would still have the same area. So that's true. And that's the same with circles with equal perimeters. The perimeter of a circle is its circumference. So if the circumference of the circle is the same, it's the same circle. It's identical, it's congruent. Whereas for regular octagons, that's the same situation as with equilateral triangles. They'll all have the same shape, but the lengths of their sides could be different. So 2 marks for them all correct, 1 mark for 3 of them correct, no marks if you get less than 3, fewer than 3 right. Okay, so we're into the D's now. So this is a question where there are an additional 2 marks for how you organize your work. I'll emphasize this again, I have in other papers as well, it doesn't mean you need to write a story. It's not marking your literacy, it's marking your ability to explain what you're doing. So a square has a perimeter of 80 centimeters. A circle fits exactly inside the square as shown in the diagram. Calculate the circumference of the circle. So the circumference of a circle is pi times its diameter. The diameter of the circle is going to equal the length of the side of the square. Now if I know the perimeter is 80, because it's a square, it has 4 equal sides. So 4 lots of D equals the perimeter, which is 80. So the diameter is going to be 80 divided by 4, which is 20. So the circumference equals pi times 20. On your calculator you have a pi button, which is shift and times 10 to the x, so we're going to do pi times 20 equals 62.83 blah blah blah. The question wants it to 1 decimal place, so it's going to be 62.8. Check the next digit, it's less than 5, so 62.8 centimeters to 1 dp. Okay, so I haven't written an essay, I'm just writing down the steps of what I have done. So the marks for that question, there's a method mark for doing 4 lots of diameter is 80 and getting a diameter of 20. There's a method mark for pi times 20 and an answer mark for 62.8, and then the other 2 are for laying out your work in an organized fashion, explaining what you're doing, followed by the maths, moving from there. In general, what they like to see is only 1 equal sign per line. I've broken that rule there, but it's laid out in such a way that they are equivalent, so that doesn't matter. So that's question 9. Question 10. Write down the nth term of the following sequence. So what you do is you look to see what the sequence, how the sequence is progressing. In this case, you can see each time 1 is being added, so it's a 1n rule. The second part of the process is to have a look at the first term. If the first term was 1, it would remain a 1n rule, but it isn't 1, it's 3. We have to add on another 2 in order to move from the 1n rule to the 3. So the rule is n plus 2 or 1n plus 2. Now not only do you need to be able to find an nth term rule, you also need to use an nth term rule. And if I use this as an example, what we have there is this is the first term because it's in position 1. This is the second term, this is the third term, that's the fourth term, and so on through the rule. So in order to work out what the first term is for this rule, I put n as 1 in. So n equals 1, 1 squared plus 7. 1 squared is 1 times 1, which is 1. So the first term is 8. Then to work out the second term, I put n as 2. 2 squared plus 7. 2 squared is 2 times 2, which is 4, plus 7 is 11. And finally, the third term, 3 squared is 9, plus 7 equals 60. Which term in this sequence is the first that has a value greater than 85? So you could write that as an inequality. What they want to know is when is n squared plus 7 bigger than 85. You could do that then by trial and error, or you could go ahead and solve it. For example, if we took n as 10, that would be 107. If we took n as 9, 9 squared is 81, plus 7 is 88. If we took n as 8, it would be 64, plus 7 is 71. So n equals 8 is too small, so it's n equals 9. Okay, so you could do it that way, or if you want to treat it as an equation, you're going to get rid of the add 7 by subtracting 7. 85 take away 7 is 78. So you're looking for the value which has got n squared bigger than 78. So n is bigger than the square root of 78, opposite squaring, which n is bigger than square root of 78, 8.8. So the answer is 9. So whether you go through it like an equation or whether you do it by trial and error doesn't really matter, as long as you end up with the correct answer of 9. So marks for that question: 1 mark for the 1n, or the n, and 1 mark for the plus 2. For this question, 2 marks for all 3, 1 mark for 2 of them. And for this question, n squared greater than 78 would get you a mark, or 2 marks for getting the 9th using whatever method you've used. Okay, so that takes us then, if we get everything right, up to the C grades, which I'll do in the second clip.